Hi, everybody. So today I'll be talking a little bit about prioritizing technical debt. So the subtext is taming the beast. I think it's a beast that a lot of us have actually seen in our lifetime as software engineers. So I'll just share a little bit about some of the techniques we have used in taming this beast. So what is technical debt, right? So technical debt usually is reflects the implied cost of additional rework caused by choosing an easy way. So easy solutions, right? Right now, instead of using a better approach that would take longer. So usually the key word here is that you take a shortcut, it will result in additional rework. So that is kind of like what a technical debt is. So words you hear from your friends or colleagues will be things like, oh, we took a shortcut. When we ask about this thing, you say, oh yeah, we took a shortcut back then, or this was a hack, we'll fix that later. So we hear words like this, it means that there's something going to happen and it's going to result in what we call technical debt. So that's usually what it is. Basically, you've done something, you take a shortcut, and it may come back and bite you later on. So broadly, technical debts can be separated into four categories. They would be things that are reckless and accidental. Basically, you don't know what you don't know. Like the question here is what is layering, for example. So that you don't know what you don't know. So that's how that way is kind of reckless. There's also reckless and deliberate, as in we don't have time to design shit, right? So that overall, like, we just want to get things done, right? So that kind of like you want to get things shipped, and you don't really want to spend time to design things because you don't think it matters. There's another type who openly goes and take on the technical debt because they know you want to prioritize delivery over, and you want to deal with the consequences a bit later on. So this is more of like you going in with your eyes wide open and say, this is a technical debt we're willing to take, and we shall take it, and we'll deal with the consequences later. There's also the fourth kind, which is unintentional. So you did something only later on after it's been deployed to production, you realize, oh, right, it's a test I forgot to write, and now it's a bug or something along those lines, like something Tenzi is facing right now. So, so yeah, so this could be an unintentional thing that got released. You never know. Yeah. So how you paying off technical debt, right? So so we talk about the categories of technical debt. So let's talk about what are the things you have to do. So essentially, like any kind of debt, you eventually need to pay it off. And when is the moment you start paying those technical debt? I will show you a few symptoms where it's about time that you really have to pay it off. For example, when the cost of change is too high, right? For example, in terms of cost, I'm talking about time, because like, for example, you hear this in your sprint planning and say, oh, it's going to take 3 weeks to implement a button. That is kind of like a telltale sign that it's going to take the cost of doing these changes, implementing new changes, new features is going to be a little bit higher than you would expect, right? So that would be a symptom of when you should actually start doing this thing. Now, I think another way you can tell that it's time to pay it off is when you have brittle code. In a sense, when you have your application, there's so many moving parts and everything is kind of interlinked, intertwined together. As the moment you change one line, all your test starts breaking, right? So that's what we call brittle tests or brittle code, right? So then one code change will result in a cascade of failures across the system, which also means that you have you're written your code in a way that's everything's so entangled. There's no way you can decouple them. So that's probably where time you also need to do this. When another way you can think of technical debt is when you need more effort to understand the code. I think there's a graph somewhere that you spend more time reading than actually writing code. In this case, you actually spend more time reading because there's so much entanglements and things that are moving that you need more time to understand before you can actually implement any new changes. Which is also why we usually, which is also leads to the cost of change being too high. Basically, you need more time to read code before you change code, right? So that's kind of like where so when you see these three things, it's not exhaustive, but when you see these three things, usually it's time you should start to pay off. So I'll show you three steps where where we've done this, and step 2 will wow you. Okay, never mind. So step 1, stop the leak, right? Stop the leak. What do I mean by this? Like, you're in a sinking ship. You have so many things happening right now, but what you want to do is you want to stop the leak, as in you want to make sure that you don't commit any more technical debt, right? So it's one of the things we should try and do. So stopping a leak in terms of that is, first of all, be deliberate in your design, in your code design. Basically, before you, when you're given a story, resist the urge to jump in the right code, but spend time to design. Think about what are the things that could happen, the different moving parts. In my team, we also do something called technical spike, where before you even start write a single line of code, we write technical spike code. Basically, we try to figure out what are the technical boundaries behind a new feature we're building, like what are the things you could do, not do, before we actually commit and work on the code, right? So design your code is important. Refactor your code as soon as it works. So in the sense that when you write code, you want to make sure that you also, because when you have written the code, the context and understanding of why the code was written is still there. It's still very fresh in your mind. So this is actually the best time to step back in and say, okay, what are the mistakes I've done? So the sense that when you kind of like what we call the TDD cycle, so the red green refactor, in the sense that when you've written, so the TDD cycle, if you don't know what it means, is when your code is first being written, where your test is first being written, your test will fail because your code is not written yet. You write the minimum amount of code to make the test pass, and which why your tests are green. And then the last step is to refactor. Basically, go back to your code and figure out what are the shortcuts I've done, what are things I could have cleaned up. So this refactor step is very important because, as I said, at the point in time when you wrote the code, your context and understanding of why the code was written this way is still very fresh in your mind. So it's probably the best time where you can do this. So why sometimes we recommend people to do pair programming, because you want to be able to like have the energy left. So when you do pair programming, you want one person to write the test, one person to write the code, and after they go back in and then refactor together, right? So that's kind of like where we can, that's where you have the energy left to do refactoring. Sometimes when you do PR reviews, you can also use that as an opportunity to encourage the developer to, hey, maybe you should refactor this or something like that. So as I said, so tests just gives you more confidence in refactoring. So having tests is a good thing. So another thing is dry is not always a good thing. Don't repeat yourself. It's not always a good thing. Why? Because sometimes you may end up having the wrong layer of abstraction. You premature optimize your code, right? So sometimes it's good to kind of hold back and say, maybe there's some repetition here, but I don't know what's the actual behavior. So wait for at least 2 or 3 repetitions before you think about refactoring or pulling abstractions or whatnot. Because the worst thing you can do is abstract your code too early and end up having the wrong abstraction, which causes problems later on. Another tip you can try to learn to stop the leak is to recognize code smells. What are code smells? Code smells are like symptoms of poor design or implementation choices. So, for example, you look at a method and the method has like 50 arguments going in. It is a smell, right? Or we find the same variable being used everywhere, and there are so different naming conventions. Like somebody use uppercase, somebody use lowercase or mixed case. There's also another code smell, right? For example. So yeah, so I have a website I would recommend you go check out. It's refactoring.guru. So it actually has a section just on this, what code smells, right? So this would be helpful. So recognizing all these things, being deliberate with your code design, doing refactoring, learning to resist from refactoring repeated code, and also recognizing code smells are all important skills to help your team stem to stop the leak, right? So basically, don't commit any more tech debt. So that's step 1. Step 2, maybe you could try and do a technical debt sprint. The technical debt sprint basically is like you spend one entire sprint working on technical depths. And the way you figure out what your technical depths are is to do this thing, run this thing called a technical debt workshop. So tech debt workshop, what we do is to get everyone in the team into the room. And what we do is get everyone to write on post-its and say, what do you think are technical depths in the code, and put them in one post-it note. Once you put it all into one post-it note each, you put them all on the board and you identify clusters. These are the clusters of code that are like, oh, the login functionality has a bunch of like, everyone agrees the login function is broken. Everyone thinks the checkout function is broken. Everything, So once you recognize these classes, you know these are important classes. You should your team recognize as technical debt, and you should probably try and deal with those. The last thing you should do is then organize them into the value, complexity, or effort quadrant, which is pretty much what the previous speaker has talked about, that quadrant of things. After that, you plan and do the technical debt recovery. So again, this is pretty much the same diagram as what the previous speakers talked about impact and effort. So here, the impact here is the value. What is the value to this change that you're making? And what is the complexity and effort needed to actually get this work done? So in the same way that we prioritize in the impact and effort quadrant, we do the same thing. So number one, we will deal with high value, low complexity stories, right? So these are basically all the cards that are clustered there. So what we do is that once we got those cards in the previous exercise, we'll start putting them into all these 4 quadrants and see, figure out, okay, this particular card, is this a high effort, what's the value of this, of doing this change? What is the effort needed to make this change, right? So you put them all on this board, you come out with this matrix of like things you should try and work on. So 1, 2, 3, 4, right? So these are 4 areas. And then of course we have the time wasters, which are the stuff on the top left-hand corner, which probably you shouldn't need to do, right? So as an exercise, we can look at this, last animation. As exercise, what would you think these stories are, right? Have a list of stories that are here. So these are potential technical debts that you can actually do and think about as a team. So for example, documentation for a shared library, removing date code from a feature toggle, audit on open source licenses use, upgrade on the latest version of Preact, or so on and so forth, right? So these all can be examples of technical debt, and I'm sure some of these are also something that you may have faced in your team and your company, right? So the exercise that would have is like, what are the value of these things? For example, documentation for a shared library, is it a high value thing, or is it or low value, and also what's the complexity of this, the effort needed to do this? I would say the effort of writing documentation is pretty low, right? So which means it's probably a candidate for doing something quick. What's the value of this? The value of this is moderate to high. So I would say yes, which should be something that we should try and work on first. Removing date code from feature toggle probably is already a toggle which already permanently turned on, so we should probably remove it. So yeah, so remove the thing. Removing the date code will be pretty easy, just about deleting code, right? And of course, making sure your test still pass after deleting code. So I would say the value here is kind of moderate to low, because date code never gets run anyway. But the effort will be quite low as well. So it's like, okay, so low effort, low value, I think we can probably do it. So in this particular case, low value, low effort, it will probably be the 4th thing you would think about doing. And the other one, which is documentation, is low value, low effort, but high value, which pretty much puts us in the 1st quadrant, right? So yeah, these are some things that you could think about, and probably your team could also think about, right? Right, so the step 3, what step 3 is? Continuously pay down your debt, right? So the truth is you can never pay it off, because technical debt will always be with you. It's like a scar that you have on your hand or your face, and you cannot get rid of it. So yeah, we can clean it up and put makeup and stuff like that. By the way, okay, I'm moving away from my script. Okay, paying down your technical debt. So what are the things you should do to pay down technical debt? So first of all, you could maybe include debt repayment stories in every sprint. So every sprint that you do, you could probably put a percentage. For example, 10% of stories in this sprint backlog should be about technical debts. So as you slowly bring in all the stories that you have drafted in your previous sprint. So for example, in the tech debt sprint, you may not be able to finish all the stories in the tech debt sprint, but you could still use the same idea, the board, to kind of bring on to subsequent sprints, and use those as stories you can insert into your sprint backlog. So you can actually use those opportunities to fix it, right? And you pull the tech debt stories from the sprint board that we talked about earlier on. The next thing to do about paying down the technical debt is to do opportunistic refactoring. So in the sense that as you're working on a story, that you also spend some time refactoring code, right? The stuff that you are working on, you also touches a lot of the legacy code that comes with it. Like your new code is interacting with old code, right? And some of these old code are probably badly written. So you can also take this opportunity to also refactor those code there. And the way you do this is to try and do it only after you're done with the acceptance criteria. Basically, after you finish your story, it's working right now, then you have still some more time left. You work on the refactoring, refactoring the other codes that your code actually deals with. But one thing you have to beware when you're doing this, that you may end up going into a rabbit hole. I have a colleague in past, a colleague in my previous company who has this tendency of going down rabbit holes. Like he will work on code, or he saw this function that he sees is very badly written. He will go into that code and try and refactor it first before he work on his production code. But when he's working on that code, he actually links to another library which also is badly written. So you go to that other library and fix that library and go and so on and so on and so forth. So he has a very low delivery velocity because he got into rabbit holes so easily. So beware of rabbit holes and try not to go into those rabbit holes. Sometimes it's good when you're doing it in a pair to time box yourself, or even when you're in your morning stand up. So you will notice one of your colleagues keep talking about the same story over and over again every single stand up. It's a symptom that probably they're going down a rabbit hole right now. So maybe you should try and help yank them out of the rabbit hole. So basically, how to prevent yourself from going to rabbit hole is allocate a time box. Like a time box means I want to put maybe 2 hours on this maximum to do the refactor. If it doesn't work, I will go back and I'll just rewind and just do some other thing, right? So this is something you could try and do, and you should help your team to be accountable. You should try to help your teammates to be mindful of this as well. Rabbit holes are not always a good thing to go into. Another thing about continuous pay down of the technical debt is to revisit the technical tech debt board once in a while. So maybe after once every quarter, we can redo the workshop again, tech debt workshop, as a way of figuring out what are the technical debt that we have now, whether we have introduced anything new in the code that is now considered as a technical debt, And so this is important for us. So we revise it with a workshop every time, right? So next thing we want to do is also add test coverage of legacy code before you refactor. So essentially what you want to do is before you, for example, you were given a task to introduce a new feature, and the feature lets you touch a legacy code. And you know that the legacy code that you're working on doesn't have actual test coverage. What you could do is you could then add test coverage for the legacy code before you actually implement the new feature over there. So that's one of the ways that you can increase test coverage, and that will basically help you in the future when you need to do more refactoring work. Also document the coding conventions and styles and design patterns that you're using. So basically what your team has, like the first step, which is to understand how to stop the leak. And you can then document those practices and conventions that your team has agreed on, that these are good patterns we should follow, these are bad patterns we should follow, right? So basically, these are bad patterns we should not follow. So once you figure out all these things, it's good to just document this as well. So that at least the newcomers who join your team will be able to understand why certain things are good, why certain things are bad. So you don't want to have to repeat yourself to every single person who join your team. So basically want to have a document that you can read, then again, okay, this is why we're doing it this way, right? So this is actually a very good HR practice, I would say. You may also try to do something more structured, which is what we call an architecture decision record. An architecture decision record basically there's quite a lot of fields there. Not just so you basically document what was the change, what was the architecture decision you have made, what was the reason behind it, and what was impact, right? So stuff like that will help in your future when someone down the road in your team, why did we do this use this for loop instead of a while loop or something like that? Oh yeah, okay, because back then we had this architecture decision record that says this particular type of loop we should try to do it this way rather than that. Right? So it'll be helpful for your team to understand why you do things. And the last part is to resist the urge to restructure until you know enough about the current and future use cases. So the extreme case of refactoring is to restructure. To do the code. So refactoring has many different types of ways of doing refactoring. Refactoring, you could just tweak one code, rename a class, make it more readable. But the restructure is a bit more of a destructive kind of refactor, which means you delete the code altogether and rewrite it from scratch. That is what we call restructuring. So restructuring can be good sometimes when you already know why all these pieces have come together, and how you could bring all these pieces together in one unifying class that rule them, more like a God class or a mother object or whatever. You could do that only when you have understood the different current and future use cases of how this code is written. One of my favorite authors and speakers in the world is Sandy Metz, and she basically has this quote: "Duplication is far cheaper than the wrong abstraction, and prefer duplication over the wrong abstraction," which is a follow-up of my earlier assertion about don't jump into drying up your code too soon, because you may be doing it at the wrong layer of abstraction. It may cause more problems and technical depths in the future. So but you may want to also check your tech lead about this. Maybe I should not be refactoring this right now. Maybe there should be some other reasons we should not refactor, or maybe it is the right time to refactor. You never know. So what is important is you communicate in your team, figure out what is the right time to do this. So as a conclusion, right? Technical debt can be managed but never quite paid off completely, because as you write new code, you may also accidentally introduce new technical debt. So be mindful of that. Technical debt can be a matter of opinion too, because sometimes, for example, some repetition results in less indirection and more readable code, right? Sometimes you know you're repeating, your code is being repeated in two places, but because it's the other alternative is to extract them into another method, which may result in another what we call indirection. So you basically need to drill down from this method to that method to this method to understand, oh, right, this is doing it. You're doing it this way because of that, right? Don't repeat yourself is nice, but sometimes repeating yourself is actually easier to read, for example. And sometimes technical debt and what constitutes as technical debt is a matter of opinion. And it's also a matter of what your team feels is a technical debt. Or sometimes it's really not a technical debt. It's there for a reason, because we didn't want people to make mistakes, like logging classes. You don't want people to break your logging for no reason, right? So stuff like that you should be mindful of. So and it's always healthy as a team to communicate that and understand that together, rather than you go off and refactor and don't care what everyone say. So be careful and be mindful that yes, everyone's opinion matter, and we want to make sure that everyone is in agreement on this thing before we jump into it. So which is why, to pay or not to pay, you have to decide as a team. So the team has to be in agreement on what is a technical debt and be able to deal with that together. And that's all I have.